morning to everyone. So today we are going to solve a numerical using the simple algorithm. We'll do it. I've taken a very common question found in most of the textbooks. It's just in a preliminary level, basically for the understanding. It's a continuation of the previous class. So I'm taking a flow along this direction. So I've taken 2 points, it is 1, 2 and the third point 3. Just to recollect what we have seen in the previous classes. We were referring to staggered grids. So all the parameters, that is pressure, temperature and other turbulence quantities, will be measured at the central node except for the velocity. The velocity alone will be taken at the face, that is across the face of this control volume. So this is the first control volume that I have marked. This is the second control volume I have marked. So the velocity alone will be measured here. So I am marking the velocity here as well as here. So here it is going to be UB and here it is going to be UC. Whereas if I consider the pressure, that will be calculated at point 1 because this being the central node. For this control volume, it is going to be point 2. So P2. So we call it as P2, right? So I am mentioning it as P1 and P2. I have shown these by dotted lines just for the understanding. Okay. Now for this question, we'll have to find out what is the velocity at point B as well as at point C and find out the pressure values, that is P1 and P2. So these four are to be found, and we of course have some given conditions also. We'll look at that. I'll write the given conditions. Velocity at point A is given as 15 and pressure at point 3 is given as 10. Then we have two momentum equations. So one is UB it is 5 plus 2.5 P1 minus P2. And next you have one more condition, that is another momentum equation at point C. So it is 5 plus 7.5 into P2 minus P3. So these are the given conditions. I'm just repeating the question. We have a flow in this x-axis and there are 3 points, that is 1, 2 and 3. We have got the points, that is A, B and C amidst these points. And we know where we are supposed to calculate the velocity and where we are supposed to calculate the pressure. Velocity has to be calculated always across the face of the control volume. So I have marked the velocity UB here and UC here, right? Next, the pressure P1 and P2 has to be calculated at the central node of the control volume, which we have seen in our previous class. So at this point 1, we are calculating P1 and at point 2, we are calculating P2, right? Now, we are provided with some given conditions, and these given conditions are velocity at point A is given as 15 and pressure at point 3 is given as 10. We don't have any idea about P1 and P2. Coming to the momentum equation, again we have expressions for representing the velocity at point B and point C. So this momentum equation in terms of pressure of the neighboring points. See B, this is B, so the neighboring points are 1 and 2. Likewise, this is the momentum equation, second momentum equation referring to velocity at point C, and we are bothered about the associated points, it is 2 and 3. So this is 2 and 3. So this is all about the given condition. Now coming to the solution part. Our first step is to have a guess value for the pressures which are not known to us. So when I say the pressures which are not known to us, they are nothing but 1 and 2 only, that is P1 and P2. So let me guess the value P1 star and P2 star. Initially I am taking it as 0, right? Now UE equals UE star plus DE into PP star minus PE star. So this is what we have learned from our previous lecture, and this is supposed to be remembered. Now our step 2 is to solve the momentum equations. Using these assumed values. Assumed values of pressure. Right? So UB and UC. I'm taking these two equations, UB and UC, that is a given expression. So it is 5 plus 2.5, and this is going to be P1 star minus P2 star. So P1 star is 0 and P2 star is also 0. So you will get the value as 5. Okay. Now again I am going to solve for UC, the same expression. P2 minus P3. So P2 is again 0. Coming to P3, we are not going to assume any value because it's already provided. So that is going to be 10. So it's given in the question. P3 equals 10. 5 plus 7.5 into minus 10. So it's going to be 5 minus 75. So it is minus 70. So UC value is minus 70. Now the third step is to find out or calculate P dash. P dash is nothing but the correction factor. Now we are going to use this equation, that is UE equals U star plus DE into PP dash minus PE dash. UE minus UW equal to 0, so this is a continuity equation. I already have an expression for UE. I am going to write the expression for UW. So that is UW star plus the same equation I am referring to, PW into, that is going to be PW. I can show you the reference points. So this is point P, this is E, this is uppercase W, and this is W, smaller w and uppercase W. So here we have taken PP minus PE. Now for this it's going to be PW minus PP dash. So that is why I have written it. Okay, let this remain for some time. Now I'm going to substitute the values of UE and UW here. That is, I know it the continuity equation has to be satisfied. So in the place of velocity at E and velocity at W, I am going to substitute these two equations. So what will I get? This is understood that UE equals UW, right? Now again, UE will be UE star plus DE into PP star minus PE star, that is equals UW star plus DW right? I just return these equations. Now I'm going to rearrange the equation in such a way that I arrive at the value of the correction factor, that is P dash. So UE star plus DE PP dash minus DE P dash will be equal to UW star plus DW PW dash minus DW PP dash, right? I have only rearranged the equation. We are still in step 3. We have not yet reached the P dash value or the P dash expression. Now let me club these terms. Here there is a pp dash and here also there is a pp dash. So I'm going to club those two terms. P plus dw pp dash equals uw star plus dw star minus ue, and we have one more term, so that is de into p dash, right? So pp dash is going to be 1 by de plus dw. Inside I've got uw minus ue plus dw, correction factor pw plus de, right? So this expression we are going to use for calculating p dash. If this small p that is going to be at point 1, then I'll be getting the corresponding correction factor of pressure at point 1, right? If this p is equal to 2, then again the corresponding correction factor at point 2 will be attained. Okay. Now I'm going to take individually at both the points, say 1 and 2. Now before that I'll draw the separate line diagrams for point 1 as well as for point 2. I'm taking only the specific points, that is point 1, point 2. So this was, here it was A, right? This is B. Now this is my point 1, so this is P, and this is going to be small e, this is the uppercase E, and here you have W. Of course you don't have any points beyond this because we had this figure in a question, right? So there was not no any specific point beyond this A, right? So there is no W, there is no capital W, right? So this is how the arrangement is. Why I have redrawn this figure is, I'm going to calculate separately for point 1. I'm going to solve for point 1 as well as for point 2. So whenever these points are changing, that is from 1 to 2 it is changing, these suffix, that is small e, small w, capital W, all will be shifting. So for that understanding I have drawn. Maybe this is the first time that you are solving, you might have some confusion, but later on you will be familiar with it. So for now you can refer to this figure. You can also try solving along with me. So this is at point 1, right? So my P is going to be 1. So here I am going to write it as P1 dash equals 1 by dE plus dW. All these are smaller case only. What is dE here? It is dB. What is dW? It is dA. So dA plus dB into, look at this UW. UW is here, right? UA. So UA star minus E is actually point B plus this is dW, so it is again dA into dW. This uppercase is no more there, so I don't have any point to replace. I will simply write it as dW dash itself plus dE. So dE is again here, it is dB into PE dash, the uppercase which is P2 dash. Right? So I have written this equation in terms of the points that I am really bothered about. Okay. Now 1 plus dA is not there. There is no dA anymore, right? So this term is again 0 only. dB, I hope you remember the initial condition equations are right here once again. That is UB was 5 plus 2.5 into P1 minus P2, right? So from this equation it is understood that dB is 2.5. So I can write, I just arrive at the values. So dB is 2.5. And what was the next boundary condition given in the question? It was 5 plus 7.5 into P2 minus P3, right? So this is for UC, sorry, this is 3. So this is UC. So this is the value of DC, right? So DC is going to be 7.5. What else we need in this question? We need dB, then UA, UB, PW, and of course this term is again not there. So this is going to 0, right? Now I'll substitute the values here. Whatever available data I'm having, I'm going to write it here. So P1 dash, this equation I'm writing, 1 by dB. So my dB is 2.5. What is UA star minus UB star plus dB into P2 dash? Okay, what is P2 dash? P2 dash is, okay, we'll have to find out P2 dash. This dB is 2.5, so I'm writing 2.5 in the place of dB, right? And UA and UB, we have already arrived at, right? We got two values of UA and UB. So one was minus 70, I believe. UB was minus 70 values. So it is 1 by 2.5. UA dash is 15, and this is 5. This is UB. It is 5 plus 2.5 into P2 dash, right? So it is 1 by 2.5 into 10 plus 2.5 P2 dash. So that is 10 divided by 2.5, it's 4 plus P2 dash. On the left hand side we have P1 dash, right? I'm erasing this lower half alone because we need this formula for solving at point 2 also. Now P1 minus P2 dash, that is P1 dash minus P2 dash is equal to 4. This is our first equation solved for the first point. Likewise, I'm going to solve for the second point also. So I'll draw the line diagram for point 2. So if this is our point 2, we have C on this side, we have B on this side, and beyond that we have again 1, and this side we have point 3, right? Now this is going to be our point 2, so this will be my P, this is small e, this is small w, and this is capital W, right? I'll erase this. Now using the same equation, my P is going to be 2, so this is P2 dash, 1 by DE is C, DW is DB, UW is B, minus UE is C, plus DW, which is B, and PW, it is going to be 1 dash, right? This is 1 dash, plus PE. So small e is our C, and P 3 dash. So these are our values. We have already seen that dB was 2.5 and DC was 7.5, right? From the given condition we have arrived this. And what else we need? dB, DC we have. Of course UB we have got the value, which was 5. And UC was, I'm sorry, yeah, it was 5 only, and UC was minus 70, right? And what about P3 dash? What about P3 dash? P3 dash does not exist. Why? I'll tell you the reason. Already we have the value of P3 in our question, right? It was given as 10. So the value of pressure at point 3 is given. There is no need for assumption. Only when there is an assumption you'll have to go for a correction. So here there is no correction at all, right? So P3 dash is again 0. 0, okay. So now 1 by DC, so it is 2.5 plus 7.5, UB star, it's 5, minus of minus 70, so it's going to be plus 70, plus BB is 2.5 into P1 dash, we do not know. Is it really P1 dash? P1 dash, yes. So it is P1 dash and PE dash, okay, plus DC is 7.5 into P3 dash. Right? So since this is tending to 0, I am neglecting this term. So it is 1 by 10, 75 plus 2.5 P1 dash. Right, here I have P2 dash. So it is 10 times P2 dash, 75 plus 2.5 P1 dash. I am just rearranging the equation because we already have P1 minus P2 dash, right? I am bringing to the same form. So 2.5 P1 dash minus 10 P2 dash equals minus 75. This is my second equation. We have two equations and two unknowns, that is P1 dash and P2 dash. So solving these simultaneous equations, what we will get? So you can solve the equations 1 and 2 and check whether you are getting the values which I have got. So the values that I have got is 46 by 3 and 34 by 3. Right? Now our step 3 is completed because we have got the pressure correction equations at point 1 and point 2. Right? What is our next step? We'll have to check whether the continuity equation is satisfied or not. What does it mean by satisfied or not? That is, we have the points B and C. So velocity at point B should be equal to the velocity at point C. In other words, UB should be equal to UC. Right? So I have to calculate UB and UC. To calculate this, what we are going to do, we have to use the momentum equation given in our question. So UB will be whatever that guessed value, that is from the guessed value of pressure, whatever we have got, I am writing here, plus 2.5 into P1 dash minus P2 dash, right? So what was this UB? Again I write here, UA was given as 15 in the question, 15 or 10. Okay, then UB was calculated as 5 and UC was calculated as minus 70, right? So I am writing this 5 plus 2.5 into, what is our P1 dash? 46 by 3 minus 34 by 3, right? So you solve this, just check for the answer. So it is 5 plus 10 and that's going to be 15, right? This is our new UB value. I'm not writing here new. The reason is whatever the final value of U that we are getting, that is going to be the U new or the latest values. I am just mentioning as UB. Now I'll go for the UC equation. UC equation is UC star. Why is it star? Because it was the guessed value which was calculated using the guessed value of pressure. Right? So plus 7.5 into, it's again P2 star minus P2 dash minus P3 dash. So UC star is minus 70 plus 7.5 into P2 dash is 34 by 3. We do not have a value of P3 dash, so this is 0, right? Okay. So you check for this value. and see whether you're getting the same 15. I have already checked and I've got it as 15. Now you can see that the velocity at point B as well as point C are equal, which means UB equals UC. So that is again UB minus UC equals 0. Therefore, continuity equation is satisfied. Right? So do we have to proceed further? No. We have seen that for the guessed values and for the corrected values of pressure, again when you find out the U and that is U, B and UC, you understand that the continuity equation is satisfied. So this will be a final value. But something else we have to do. What is that? We'll have to revise our pressure values, right? So our new pressure value will be whatever we have guessed plus the correction that we have got, right? In case of P1, what did we guess? Our guessed value was 0 plus what was the value that we have used? That we have got, it was actually 46 by 3. So this is our new value of pressure. And likewise for P2, it is going to be the guessed value with that of the correction. So guessed value was 0 and the value that we got was 34 by 3. Right? So 34 by 3. So this is our P2 value. Now we'll see what all results we have arrived at. We look at the results. We have attained the pressure value, that is at point 1 and 2, as well as B and C. So what are these? This is 46 by 3. Use the appropriate unit. This is 34 by 3 and this is 15 and again this is 15. Okay. Now say for example, you didn't get this either one as 15 and say it is 25. What you would have done? Again you would have gone for the revised values. We must be having a revised value. So based on the revised value, again you go calculate the velocities at the two particular points, right? So it keeps on going for a number of iterations, right? Now we were provided only with the velocity at point A and the pressure at the last point, that is at point 3, and we were given the two momentum equations. Now when we look at the momentum equations, it is very clear that we couldn't proceed because we don't have P value as well as U value. So we have gone for guessing of P values, right? So by this guessing method, we have arrived at this condition. Now I have taken a simple one-dimensional problem, right? That is, I have taken only the x-axis. That is, I was worried only about U. So if you are going to consider a two-dimensional problem, that is U and V, we have seen this figure earlier. So this is, so if this is the case, then I'll have to calculate not only U at E and U at W, but also I have to calculate V at N and V at S. You can try one such problem. I would advise you to just go through Patankar textbook, so that will be useful, or John D. Anderson. You can refer any of the textbooks that you're comfortable with. Just try out a 2D problem and see how many iterations it's going on. Once you learn, once you are exposed to the hands-on training in a CFD software, you can try these type of problems there also, right? So any doubts, you can post it, or you can also mail me, or you can also ask at the end of this session, right? Thank you.